With solving radical equations, we're going to split this up into two parts. So for the first part, we're going to be looking at equations that are a bit more simple, and then with part two, more complex. So an equation with one or more radicals containing a variable is called a radical equation. And we can eliminate or get rid of the radical by applying to both sides of the equation the power equal to the index or root of the radical. So steps for solving a radical equation. The first step is to isolate the radical, which means to get the term containing the radical alone. So if an equation has more than one radical, we may have to choose one of the radicals to actually isolate. The next step is to raise each side, and that word side is going to be very important, each side of the equation to a power equal to the index or root of the radical. And then we will be solving the resulting equation. We will also need to check the potential solutions in the original equation. There will be times when a solution does not check in the original equation, and therefore we call this an extraneous root or an extraneous solution. So we're going to work together to solve these radical equations, and each time we need to recognize the root and also recognize the importance of checking our potential equations in the original equation. So first we're going to solve the square root of x minus 5. So notice that the root is 2. So we're going to take each side and raise it to that power to undo the root. So the square root of x squared, I need to keep this equation balanced, so I need to take 5 and also square it. So the square root undoes the square power and leaves us with x. Therefore, x is found to be 25. And then we're going to check this. So we're going to let x be 25, and we're going to substitute this into the original equation. So we have the square root of 25. Is that indeed equal to 5? So remember, with a check, you always simplify all the way through. So we see that 5 is equal to 5, and this is showing us that this is a solution. For our next equation, we have the square root of t plus 5 is equal to 0. So remember, your first step is to isolate your radical, which means we need to get rid of this 5. And we can do so by using inverse operations of subtracting 5. So we are finding that the square root of t is equal to negative 5. Now this is the square root, so our root is again 2. Our index is 2, therefore we're going to take each side and raise it to a power of 2. And so notice on the right-hand side, we also have this negative. So this is negative 5 squared. And the square root of t squared leaves us with t. And negative 5 squared is equivalent to positive 25. And so now when I go to check this, we have the square root of 25 plus 5 is supposed to equal 0. But the square root of 25 is positive 5. And 5 plus 5 is 10. It is not equal to 0. Therefore, this is what we call an extraneous solution or an extraneous root. And because that was the only potential solution for this equation, this is actually an equation that does not have a solution. So this was never able to be solved. Your question is to solve the square root of x minus 7 set equal to 2. Next, let's look at solving the square root of a plus 1 equals 3. So our root is again 2. So we're going to take the square root of a plus 1 and square it. But to keep this equation balanced, we also need to take 3 and square it. So the square root of a plus 1 squared is leaving us with the base, and the base is a plus 1. 3 squared is 9, and now we need to solve this equation by subtracting 1, so we have a potential solution, a equals 8, and we need to check this. So letting a equal 8 in the original, we have 8 plus 1 underneath our square root, and this is supposed to equal 3. We have the square root of 9 equals 3, and 3 does indeed equal 3, so this is a solution. For question number 4, we need to recognize that the root is not 2. It is 3 because this is a cubed root. And so we are going to take each side and raise it to the 3rd power. And the cubed root of 2b cubed leaves us with the base of 2b. 4 cubed is 4 times 4 times 4, which is 16 times 4, which is 64. And then we need to solve for b. b is not alone because it's being multiplied by 2, so we're going to undo that multiplication with division. So b is equal to 64 divided by 2, or 32. So that is our potential solution. So we have the cubed root of 2 times 32 is supposed to equal 4. We have the cubed root of 64, and that is indeed 4. So this is a solution. Your next question is to solve the cubed root of r minus 1, and that is set equal to 7. Example number 5 is our first example where we have more than one radical. But notice everything is contained within the radical. So we're going to first identify that the root is 4, and then we're going to raise both sides to the power of 4. So we have the 4th root of s plus 1 raised to the 4th power is equal to the 4th root of 2s minus 3, also being raised to the 4th power. And so the 4th root will simplify with the 4th power, leaving us with s plus 1 equals 2s minus 3. And we need to solve this equation. And we can do so in one way. We could subtract s, and we can add 3. So that gives us 4 is equal to s, or s is equal to 4. And let's check that. So we have the 4th root of, so we have a potential solution of s equals 4. We have 2 places to input that. So we have the 4th root of 4 plus 1 equals the 4th root of 2 times 4 minus 3. 4 plus 1 gives us 5, and so we have the number, which is the 4th root of 5. And on the right-hand side, we have 2 times 4, which is 8. But 8 minus 3 is 5. And even though these are irrational numbers, they are equal. That's the only thing we're checking for, is the left side equal to the right side. and they are. So this is a confirmed solution. Problem number 6 is quite interesting. So first, please recognize that we have a base raised to a fractional exponent. So we have r minus 1 raised to the power of 2, but we have division of 3, which means that this is the cubed root of r minus 1 squared. And this is equal to negative 3. So to undo the root of 3, we need to take the left side and raise it to the power of 3, and the right side and raise it to the power of 3. And this leaves us with r minus 1 squared. And then notice on the right-hand side, this is negative 3 cubed, and a negative times a negative times a negative gives us a negative 27. And take a few moments there. Notice r minus 1 is being squared. Whatever this is, the least amount that this could ever be is 0. Because if we take any number, subtract 1, but then square it, squaring any number will result in a number that is positive or at the lowest 0. It is impossible for this to ever be negative. So this will always be greater than or equal to 0. Therefore, it is impossible for this to ever give us a negative. Therefore, there is no solution. Your third question, notice the left side, we have cubed root of our base, and the right side, we have cubed root of, and then the base there.